here in the ugly part of my basement. It's really all an ugly part. This is where I store my pressure washer during the winter months so it doesn't freeze. And I also keep my Catrike down here under its dust protection in the off season. I'm getting ready to use the pressure washer on the first reasonably warm day to clean off all the salt and other garbage it gets on the garage floor after a winter of parking cars in there. And to that end, it made me mindful again of the pressure washer's hose, which is, as most pressure washers have, it's kind of a thick-walled, fairly stiff PVC material. I think it's PVC, or something similar anyway. And it doesn't like to be bent very sharply. It can kink pretty easily. It's best to, let it have a fairly generous curve to it. And it's kind of bulky, and it's always been the part about using the pressure washer I hate is carefully unreeling it so it doesn't get a twist or a kink, and then rolling it up so it doesn't get a twist or a kink, and trying to get it in that diameter. I've always used some rather tortuous way of doing it. So I'm going to build a hose reel for this, and it's going to have dimensions suitable for this. I did not find a commercial product that I could just buy that would do this. Reels for electrical cables are much too small in diameter, and while some garden hose reels are about right, then they often are way too big, or they don't lend themselves to being cranked up to reel something like this in. And they're usually designed for a lot longer length of hose of a larger diameter, so again the dimensions don't work out. So it called for a custom-made hose reel. The goal is to buy as little as possible and do this fairly quick and dirty using materials that I have on hand. The only things I really expect to buy might be a couple of nuts and bolts and probably a bit of sheet metal. All the wood and other fasteners, glue, varnish, dowel, all that type of stuff should be things that I already have on hand in my workshop. Alright, well, I've figured out my dimensions. I want a 24-inch outer diameter disc for the two sides of the reel, and then an inner diameter of 16 inches. That will leave 4 inches here and 4 inches here for the hose to be reeled up. It won't even take 4 inches, but I want a little bit on the excess. And I was going to make it only 3 inches wide, but I think I'm going to go with 4 inches. You can see here I had 3 inches between the two side panels or side discs, and that's just not very much, so I think I'm going to open it up to 4. Maybe even a little bit more. It's going to cost me almost nothing to do it that way. But 4 inches seems such a happy number on that. I think that's what I'm going to go with. Sorry about the splotches on the image. Those are pieces of dust or dirt that have gotten inside the lens assembly in this camera that I just use for shop work, because it gets covered with sawdust. And I started to take it apart, but it was going to turn into such a mess I decided to leave it with the blotches. Anyway, so I want to keep this as lightweight as possible. I'm using 1/4-inch plywood for the two side discs, and then instead of building a heavy central core, it's going to be more like this, where these are the two side discs. I'm going to have just a ring of 1/2-inch plywood going all the way around from here to here, and that'll be glued and probably pinned to the sides for strength. And then I'm going to cut some sheet metal into a strip that's 4 inches wide and wrap it around and secure it with sheet metal screws or wood screws, but probably sheet metal screws into the 1/2-inch plywood, and that should keep the two sides locked together. they shouldn't be able to shift or rotate that way. And there will be a hole cut through the middle of it, through the center of the disc, and that'll have a 1/2 inch reinforcing piece glued and probably pinned onto it, like you can see here. And that'll be for the central shaft to go through. For the crank, I have to figure out exactly where it's going to go on the diameter, and it'll be easier to see that once I've built it up to a certain point. But I figured to have just a reinforcing block of 1/2 inch plywood at one point on the one disc, and then put some sheet steel, just some scrap that I'll cut off, and a detail of that is here. So this is the 1/2 inch plywood. The center is going to be drilled out to clear the nuts. The idea is that I'm going to have a crank handle made out of a drilled out dowel rod, a long bolt going through, and this sheet steel plate here will be drilled and tapped for the 1/4 20 bolt. And then there's going to be a locking nut up against that plate that'll just fit through the hole that's drilled in the 1/2 inch piece and the 1/4 inch disc. And I have to leave enough clearance in there that I can get a socket wrench in there. So I'll put the bolt through the handle until I get it tight, but not too tight to pinch the handle, and then tighten up the lock nut there, and that should work well for the crank handle. I'm hoping that I can make this lightweight enough, and the hose isn't very heavy, that I can hold it with a handle on one side, almost like you'd hold a cord reel for an electrical cord. And that'll just be a piece of dowel that goes through. There'll be a 1/2 inch plate, and then a larger piece of dowel, and then the dowel that goes through. And it's going to have a brass insert stuck in the end of it, and it's supposed to come out flush with the other side. And then if I just want to do it with one handle on one side, I can put a 1/2 inch piece of plywood on there, and then put through a 1/4 20 bolt with a washer, and screw that into the brass insert. And that should make it so I can spin the whole disc on that one side loaded handle. If that turns out to be too much, or if I want to put this on some sort of a stand, I can just undo that screw, pull that out, and instead, or I can keep that on there and put another handle on with a bolt going through the handle and then screwing into the same brass insert. So it's just an alternative right side. Then it'll have two handles, one on each side, that I can just hold it with the two hands and play it out. But of course I can't reel it in that way. And that handle on the right side would get in the way of cranking the actual crank. So I probably won't use it that way. But the other thing is I can just stick a length of dowel rod or conduit or whatever, piece of pipe through there, and put that on some sort of a stand and just reel or unreel it in that way. So there's several options here, but the main thing is to get this main disc assembly, the actual reel, and then all the variations can happen after that. So the first thing I need to do is cut out a 24-inch diameter disc, two of them actually, from the 1/4 inch plywood, and then I need to use my beam compass to draw out in 1/2 inch plywood. I'm probably going to make 1/4 arcs like I've got it sketched here, and cut those out. They won't use up too much of a piece of 1/2 inch plywood that way. I can kind of stack them. I'll need 8 of them total, and then assemble them on the disc, and again glue and screw them. But the thing I need to remember is I'm going to put in these screws going in this way, and I'll probably want to pre-drill the pilot holes in there. And how I'm going to get my drill in there, since it's going to be about 4 inches from here to here, I don't have a long enough drill in the right size to do that. So I may actually try to measure this out in advance and pre-drill the pilot holes for the screws, And then once I've done that, then before I completely assemble this, lay the sheet metal on there and mark where the holes are onto the sheet metal, drill those out, then do it for the other side, and once the sheet metal's got 2 rows of holes on it, then I should be able to assemble it all. I'm hoping that approach will work. So I just got my beam compass set up for 12 inches and centered. You can see where I've got the circles marked out there. And another one over here on this side. Alright, the 2 sides are made. I've marked out my 8 quarter circles. And I just realized I may have exceeded the ability of my bandsaw to cut that. We'll see. I think I can work at it from the small side out and still have it clear. Alright, there's all the crescents cut out and sanded. Here's one of the 1/4 inch discs with the 4 quadrants of the inner ring test fit onto it. All looks like it came out right. Fits within the 16-inch diameter circle I'd drawn on here. Now I have to arrange to put these on here temporarily for the purpose of fitting the sheet metal on, and once that's done, then I'll pull them back off and put them together more permanently with glue. So I just ran some drywall screws through from the outside of the disc and into these sections just to hold them in place. And I think the next task is to cut the 4-inch wide pieces of sheet metal. And what I ended up buying was some aluminum. It's probably about a 32nd. No, it's thicker than that. It's not quite a 1/16 of an inch, somewhere between 32nd and a 1/16 of an inch thick. I think it's about the right thing. I was going to use some galvanized steel or sheet tin, as it's often called, like used for air conditioning duct work. That would have worked. I wasn't sure it would hold up as well to moisture as the aluminum would, so I ended up going with the aluminum. Now I won't be able to cut this on my sheet metal shears because it's too wide, so I'm just going to have to mark it and cut it with my sheet metal snips. And there are the 2 long lengths and 1 extra length to make up the difference that I calculate I need, plus about a 1-inch overlap between each section. I just remembered that I had this chuck for my Dremel cable attachment. So my previous concerns with how I'm going to drill straight into this 1/2-inch ring with this 4 inches here are now alleviated, as I can just go in and drill in almost perfectly straight. That'll make things a lot easier, but otherwise I was just going to painstakingly do the first one like I've done it here, and then start wrapping the metal around and mark where all the holes are, then take these rings off, drill them normally, put them back on, and then, you know, put the screws in. But I'm probably still going to do something like that once I do a preliminary fit up of this. That's just showing how it'll fit in there. And the 2-foot length from the 2-foot by 2-foot piece of aluminum I bought almost goes 180 degrees, but not quite. And that's why I need this filler piece plus the slight overlaps. Now I have to figure out where I'm going to put the crank. I have to be mindful that if I'm cranking this, it can't be any closer than the wheel allows it to get to my chest, and I have to be able to reach the crank on the outstroke of my arm. So that's about here. So what does that end up being? That's 5 inches out from the center. That seems pretty reasonable. So I'm going to now make my reinforcing plate for the crank on one side, and then make the 2 hubs to reinforce the center, and then cut those holes, and then I can glue and pin these. Then I can get towards putting the whole assembly together. And there are those 2 hub pieces and the crank handle reinforcing block. And now I'm starting to glue these curved pieces on here. I'm just going to keep the drywall screws in there, I think, permanently. It'll hold the edges down. It'll also provide sufficient clamping for the glue. Okay, I've got the rings on there and also the hubs and the reinforcing block for the crank handle. In this case I just have some scrap sticks spanning the crank handle block and the hub with a 1 gallon liquid weight on top of it. And then similarly here, but it's not spanning 2 things, it's just on top of the hub. And they're aligned with a small drill bit going through the pilot holes in both places. So I've got to... Oh yeah, I also realized after I did it I had to get my scraper out here. See if I can pan out a little bit. Get my 90-degree scraper and go all the way around here and clean the glue out that was squeezing out, because it would get in the way of the sheet metal going down there, and I didn't want to have to scrape it out after it was dried. So luckily I caught that in time. So I've cut this 2-inch by 2-inch piece of 1/8-inch steel, which I'm going to use as the handle, the crank handle support plate. I need to put corner screw holes in, and then another hole in the middle, which will be tapped for the actual crank handle, which is a 1/4 20 bolt. Tapping the center hole with a 1/4 20 tap, and my 1/4 20 bolt fits in there real well into the threaded hole. I'm probably going to paint this metal plate. Okay, for the crank handle I want the maximum OD to be about 1 inch. This is 1 1/4 hardwood dowel that I have in my scrap pile. And I've got this 1/4 20 bolt. I want the head to be recessed into it a little bit, and it's going to be 4 inches from the tail to the head of the crank handle, and then the bolt will be a bit longer than that. I can put my scale up here and see where the 4 inches will come to, and then the rest of this will be something that sticks through the metal plate, and the runout will go inside the reel where you can't see it. So I need to start out by cutting off a chunk of this, and then I need to bore it out for the 1/4 20 clearance, and also clearance for the head to be recessed. So I'll start by cutting it a bit shorter, and then I'll chuck it up in the lathe and see about boring that out. Well, I'm going to do the cheap and dirty thing and see if this works. I've got a spade bit, 9/16 spade bit in here, and this is my metal lathe. I've clamped this down pretty tight. I'm going to go at it real easily, and I'm going to step out of the way in case it goes flying. all that centered either, which is disappointing. It seemed like it started out better centered. I think it's because it's wobbling a little bit in there. Okay. Well, that kind of worked out, but I was definitely off center. I didn't bother to true up my tail spindle here to see how well it lined up. It might actually have been setting a little bit low. But the last time I used it, I thought it was pretty well centered. But I think, since I don't need this full diameter, if I can get it chucked up in my wood lathe using that as a center, then it'll be all right. Well, the I suddenly forget the proper name for this, but this hole is a little too deep for it to find the center, so I need to make a new center. I'm now turning this smaller piece of pine dowel down to the 9/16 diameter to fit in there, and then I'll cut it off flush and make a new center for it. Sort of like that. And now I can rechuck this up in here and find the center there. Okay, so that's in there now, and I can start turning this down. I just need to make sure I don't make it much smaller than 1 inch at the big end. Alright. Okay, a slightly tapered handle. Tapers from big near the tail end. Which one's the tail and which one's the head? This is the part that'll go up next to the plate, and this is the part that'll be out in space with the recess in it. I managed to chip out just a little piece around the outside, so it's got a bit of a flat spot in it, but I'm not going to remake the whole thing just for that. And I made just a little bit of a decorative ring in here. So that's just about the right size to crank on. Okay, it's time to cut out the guards for the two handles now. I'm making these 4-inch diameter, just like the corresponding pieces on the inside. And now I'm using a 3/4 inch Forstner bit to cut out the axle hole. My sort of vague plan is to use 1/2 inch conduit, which has roughly a 3/4 inch OD, to go through the hole like that. And if this is a standing axle, then that's what I'll use, just a piece of scrap conduit. But I also need to make the handheld version, so back to producing that, it's going to have to be turned down from some hardwood dowel that I have to get that diameter. And here's my crank handle with its painted metal plate and the nuts. I have to find my socket wrench and figure out what the OD of that is, so I can make a clearance hole in the reinforcing block. So this will go on about here. Try to center it up a little bit. my usual rig to find the center of a circle. I just have my 45 degree and my 90 degree, and I just mark along here and then turn it a couple of times and mark it again, and where they intersect is the center. Okay, time to turn this like 1 1/8 inches or so down to about 3/4 of an inch. So there will be some cutting going on. Okay, doing a diameter check. It's good. Just a little tight right in this area. You got to take that down. Looks like it's the right diameter. And now it should turn down just a little bit on this 1 1/4 down to 1 1/8 for the side handles. Looks good. And I'm boring out the left-hand handle for the turned down dowel I just made in an earlier step. Okay, that fits in there pretty well. That's my left-hand handle. And a hole of the same size in the left-hand guard. Like that. And that'll all be glued up. And then we have to make sure we've got, just as a sanity check, 4.5 inches will be out to here. That'll be the width of the reel. And then another 1/8 will be to here. And that'll be to just for general clearance tolerance. And then the rest of this, let's see, we'll lose another 1/2 inch. That's to here. That'll go through the, yeah, so then there'll be just enough to stick into the other plate. Then I'm countersinking 1/3 of the way through this 3/4 inch. I've got a 1/4 inch recess cut with a 1 1/8 inch Forstner bit. And my right hand handle drops into that just like this. I forgot that I have to make a 3rd guard for the version that doesn't have a handle on the right hand side. So there's that new one here. Okay, the left hand side is now glued up with the axle inside the handle and going through the guard. And now the right hand handle is glued into the recess in its guard. And I'm just checking that it's reasonably square. Looks pretty good. Something just occurred to me. When I have this hose reel in the garage or wherever, I don't really want it rolling around, and it might make sense to just make a bit of a flat, maybe right about here, on both of the side plates, just so that it's, you know, it does have a flat spot to sit down and not roll. So I think I'm going to do that now before I forget. Okay, I think that's much better. While I'm going to varnish all the wooden parts just for stabilizing the fibers and giving some protection against moisture, since this will after all be used with a water hose and possibly stored in the garage a lot of the time, I am concerned more about the end fibers on the exposed edge of the 1/4 inch plywood in particular. I don't think that the varnish alone is going to be adequate for that. So I've got some of this product I've used before. PC Petrifier Wood Hardener. I don't know if it's an epoxy product or what, but it soaks in and cures and holds the fibers together. So I think I'm going to apply that along these exposed edges. Okay, well, I've bored out and I screwed up on the centering. The drill just wandered. So I can put this threaded brass insert into there. I think I can compensate for it being a little off-center. I don't think that's going to kill me. Okay, I've got this countersunk good and deep for the head of the bolt, and this one's countersunk down through the guard plate and a little bit into the handle to hopefully receive this. It's generously cut there to allow for some offset alignment because of this not being quite on center. The bolt will define the center, so it doesn't. I can drill the hole hopefully for the bolt right down the center, and then this clearance here will allow this axle to move around a little bit in there and find its center. It's going to be hard to chuck this up in my metal lathe, so instead I'm just going to trust that I can do a decent centered job using my drill press. I do at least have the guard plate to use as a base to stabilize this so it won't tip, and I should be able to hold it in position and not have the drill wander. The number H drill bit I have won't quite go all the way through, so I will have to drill a little bit from the other side. Well, that seems to have worked out pretty good. Okay, I've got my bolt in there. It's coming through centered here. And I've got the thread started here. Let's see if it is the right length. Okay, it's all snugged up. And I'm hoping I still didn't screw up somewhere. I should have 4 inches plus a ½ inch for the outer braces, the outer panels. So that's 4½ inches. Looks like I've got almost 3/8 inches of slop, which is a bit more than I'd anticipated. I screwed up somewhere in my dimensions, but I'm not going to go back and drill out that brass insert. It doesn't hurt at all to have a little bit of extra play in here. It'll end up being just a little bit more than a ¼ inch on each side, which is really fine. Probably cut down on the friction. Well, when I ran to the hardware store earlier to get the whatever we're calling this stuff, the wood hardener, I forgot to get the fender washer I was going to get, because my original plan had been to put this up here and then use a fender washer to put through this short bolt into there when I'm using this one-handed. But since I don't want to make a whole other trip just to get a fender washer, I think I'm going to build a fender washer. Okay, there's my regular washer with my wooden fender washer made out of 1/4 inch craft plywood, and it won't stick in any further than the brass insert goes, so that's good. Okay, that's all going in there. Okay, so I need to have at least 4½ inches between here, and I've got 4 3/4, which is just about right. Slightly on the generous side. So that's when that's when I'm holding it like this. I'm debating whether I should glue my fender washer onto the guard or not. Not sure it'll improve things, but I would kind of like to have the pieces stay together when I dismantle it, so maybe I will glue it up. In this one small metal plate, the one that's going to fill in the gap, I've cut 3 or 4 chunks out so I can thread one of these Velcro hose straps through it, and I'm just going to put one little sheet metal screw into here to anchor it. And there's that. I also managed to screw it into my backing wood piece there. There we go. Built just about the way that modern appliances are built, really, when it comes down to it. Anyway, I think this should be sufficient for securing the hose on the reel so it won't just spill off. I was thinking about putting 2 of them on there, but I think one should do it. If I really need to, I can put another one on the other side. I won't be able to cut it out and thread it like this probably, but I could still secure it with a couple of screws and washers. So I've got my first jam nut and a backup jam nut on here on the crank handle, and it turns freely, but it doesn't have excess slop. If I ever need to redo those, I'll just undo the 4 wood screws that, or sheet metal screws rather, that hold this bracket to the wood backing plate. And I'm waiting for the wood hardener to fully cure overnight along the edges of the plywood. And first thing in the morning, I'm going to come in here and give it a couple coats of varnish, and then hopefully that should be dry with the help of my heater fans by the evening, and I should be able to finish assembly by screwing on the metal strips, and then it should be ready for use. And I'm hoping that on Sunday, because today is Friday, tomorrow is Saturday, hopefully Sunday will be the day I take the pressure washer out of the basement and put it in the garage for the season, and I'll get to try this out. Alright, first coat of varnish on some of these. And as usual, I've got my heater fans going, 3 of them in this case, to keep the area around here both circulating air and warmed air. Gets up to about 70 degrees, which is more than enough to cure the varnish fairly quickly. So I'll have time again today for a second coat, and then assembly this evening, hopefully. And then we'll see how well it works. And by the way, this I did another video on this, but this system I've been using starting earlier this year to keep all my varnishes and stains in bell jars, and use my homemade drill operated stirrer, is working so much better than keeping them in the original cans they come in. Well, here's a small last minute refinement at 1 in the morning. I just came down to check that the varnish was drying enough that I wouldn't have any problem with it in the morning. And I was thinking, I've got these 2 different methods of supporting the axle. The 2-handled approach, where this is the second handle, and the no handle on the right approach, where this is just a plate to secure the end of the axle. And I can only use one at a time, but then I'm going to have this loose piece. And I thought all sorts of things like, well, I'll put some Velcro on it and stick it to the side or something, and all those were too kludgy. And what I ended up deciding to do was drill a small hole and a large hole on the side that does not have the crank, so that when I'm not using this one, it'll stick in there like that. And when I'm not using this one, it'll stick there like that. At no point are these any taller than the guard for the handle so they shouldn't get in the way of anything. Now, how to hold them on there, again, I thought about using Velcro and all sorts of other things, and what I ultimately decided to do was just epoxy a little piece of 1/4 inch plywood, some scraps onto there, and then drill through a hole in these two guards for a 10 or a 1/4 20 bolt that I have another one laying around here. And I picked that size because I happen to have 2 1/4 20 brass inserts in my junk drawer. So I've drilled these out here and here. I'll put these inserts in with a tad of epoxy. I have to put a touch of something to seal the wood here. Probably I won't bother with varnish. I'll just mix up a little more epoxy and smear it around there to seal the fibers on there. And then, for example, when this one's on here like this, I'll just take my bolt and run it through there and screw it into the brass insert, and that'll hold it in place. I only need the one bolt because it'll always be holding the one that isn't in use. Alright, I've got the brass inserts in there. I've smeared epoxy around the rims of the holes, including the small ones here, which I'm going to do a little bit of light sanding on in the morning, and just to get rid of the bumpiness from the epoxy. And then it should be ready for final assembly. Okay, now for the most interesting part on this, joining the two halves together with the sheet metal strips. I decided it wouldn't hurt to have some jury-rigged clamps that'll go at 3 places around. Just slot in like that and then tighten the sheet metal screw in just so it points in just a little bit to get a grip on it, and that'll hopefully hold the two halves together. There's 4 inches between the cuts, so it should be exactly the right separation, and I can relocate them if they get in the way or just need to be moved for one reason or another, and they're quickly made and disposable. Okay, that's how that's working out. And with the axle put in place in the middle, and they're both set on their flats down there to assure initial alignment. Okay, I'm starting with my first aluminum strip, pre-drilled from the earlier step, about every 4 inches. And I've got an appropriate pilot drill in my Dremel flexible cable so I can get in there pretty easily and drill the holes. Start with the first 2 and then work my way down. Okay, this clamp here was in the way of these holes, so I used the easy loosen the screws, push it over a little bit, and tighten the screws method of realignment. Alright, I'm almost halfway around. You can see the inside there. I'm down to the last holes, and I want to get an overlap. So I bring up my next piece, slip it between the plates down there, and do the overlap at the first set of holes and continue on. Since it's a tight fit, deliberately so, between the side plates, and I need to knock this in this direction, I don't want to ding up the aluminum, so I'm just using a block of wood here that I'll tap on with my screwdriver and drive it a little bit down. And I've worked my way around so now there's just the small gap that I expected, and you can see down inside there. So now I've got this filler piece with the cable strap on it, and I'm thinking that I will just put the first set of screws on there. Oh wait, no, it has to go the other way. No, but then that's going to put this one not over the gap. This piece is a little bit too long. I cut it longer just in case, so I'm going to have to do a little trimming on this before I screw it into place. In retrospect, I shouldn't have pre-drilled the securing holes on here because they didn't work out inevitably. So I've drilled new holes now after cutting it short. Just have to mash these down now and hope the holes I made align properly. Okay, the reel is whole. What I want to do is put one more sheet metal screw at each overlap just to hold them a little more firmly together. Alright, that's the center screw. I definitely end up with more slop here than I wanted, but short of making a whole extra plate on there, I don't think it's going to harm it to have a little bit loose. It'll still roll just fine. And here are my two docking ports. So I'm going to fit the handle I'm not using at the moment. Oh, I need to sand that out a little bit. I made it a close fit, but with the epoxy lining it's just a little bit too much. So I have to go around that with the sander again a little bit. And now I'm going to screw on the bolt here, but I don't want all that excess, so I'm going to cut that off first. Alright. Okay, there is that. I made a small miscalculation in my alignments, and this handle here is 4 inches long, or was 4 inches long, and when it docks in its docking position over here, I thought I had it offset enough that it would not hit anything associated with this, but it did by 1/4 inch. Just clipped the side of it, so I went and bandsawed off 1/4 inch here, recountersunk it a little bit, and so it's just marginally shorter than it was, but it still fits. And obviously, if I'm going to use these, then you have to do it in such a way that the handle doesn't clip you when it comes around. But you know, that's if one person's holding it while another person's pulling the hose, the reel off or something. I don't envision this being used very often, but I could also sit it down on a cradle or on a couple of stacks of cinder blocks or a couple of sawhorses or whatever, with these just sitting on there, and then pull it off myself. There's a number of possibilities, or as I mentioned before, I can just stick a piece of conduit through it or another piece of dowel, whatever, but it's nice to have this handle here for a contingency. Okay, with this right hand handle off and with its trimming, it now does fit into there, and I'll put my spare 1/4 bolt in there. It's really a little longer than it needs to be, but that's okay. I was using kind of what I had around for the most part. There, so now that's held into place. And this one would similarly be stowed there when not in use. And there might be times when that's the case, such as if I'm just putting a conduit through as the axle. This way nothing gets lost. Okay, so I put this into the countersunk area, and I use that same bolt. Okay, there's that on there. It's the cranking side and the one handle holding side if I do it that way. I tried to keep this as light as I could using thin materials, and when I had to use thicker materials, using a minimum of it, using aluminum here. And this would be tiring if I had to do it for very long, but I could probably hold it out here for a minute even with the weight of the hose added to it. So that should be far more than is necessary to reel the hose in. And it does sit on its slightly flattened base. Since I don't plan to change configurations on this very often, the longer bolt that's used for this stowed handle here, it's too long to be stowed in that position, so it's going to be stowed in the guard plate's alternate position here, just going through its brass insert. But since it's a long piece, I don't think I can feasibly do it from the inside out by reaching through, so I'm just going to use my drill to run it in there, and thereby have all the pieces stowed with the reel. And it goes almost all the way through, certainly enough that it won't be a problem. Right now it's hitting the inside. I hadn't intended to stow it there, that was sort of an afterthought. So that is the completed reel. So just with this one hose, I could have had this distance a lot smaller, but I have another hose that I use if I need to get further away, so it would be up maybe about that high, which is why I made allowance for it. Now, of course, I didn't know exactly where the end of the hose was going to come, so I only have that one Velcro strip, but I'm going to get another one to tie off the loose end down here. So I think this has been a success. You know, obviously there's some water on the wood, but I've got double polyurethane varnish on there, every surface. I don't think it's going to hurt the aluminum much before it dries out. And it's pretty easy just to carry like this.